Okay, so P equals to E over T equals to VI equals to I square R equals to V square over R. Have you seen this before?
No.
No. Yeah, no. Okay. Have. Here. Somewhat similar. Okay, but yeah, we are using this basically. Okay, so let's go through these equations. So P equals to E over T, and it also equals to VI. Okay, so maybe we can express it in two ways. Okay, so P equals to E over T, right? When do we see this? We see this as a general formula for motion. Okay, so for work energy power. That means if I have an object, I'm going to move this thing around, right? I have force and I have work done and all this stuff. So if I have a motion of an object, right? If I bring this higher, lower, that kind of stuff. So this is a work energy power. For electricity, right, we are using P equals to VI instead, voltage times current, because I mean literally everything in electricity has voltage and current inside it. Right, so what's the individual versions of the equations? I can sub in the kinetic energy, the potential energy, and things like that. So for work energy power, you substitute the E, what do you get? You get half mv squared over time. That is when energy is kinetic energy. Can, right?
Yeah.
Okay, then after that, we can also use mgh because, it's gravitational potential energy over time. Or we can also use F times D, force times distance, Ft, divided by time. And we also mentioned that this d over t, distance divided by time, is actually the same as speed, as velocity. So we can say that it's equals to Fv as well. So that's our 4 equations from the work energy power chapter that's related to power. So similarly, we are going to expand on this, but now for electricity. So electricity, P equals to Vi. Now, we know that V equals to IR. So if V equals to IR, then what is V? V is just this, and that means that I can put it as I square R. Can see how we get the I square R? We get one I here, we get another I here, so there we go. Then the R is here. Okay, what about the other version? What if we get rid of I instead? So to get rid of I, right, using the V equals to Ri, I can say that I equals to V over R. And therefore, if I substitute V over R inside the I, then what do I get? I get V squared over R. Can see as well? So all in all, this is how many equations are? 8. So these are all the equations related to power. Okay, and all their individual versions you can possibly use. Right? Okay, so all in all, which ones do you really need to remember? The big ones. And then from there, you can derive them using your individual equations. Okay, individual equations. Yep. So that's your power equation. Okay, why do we want to do this? Because when we calculate this, then we can actually start to figure out how much energy is going to cost us, basically how much money. So we're going to calculate our power in this setting. Okay, so we'll calculate power in kilowatt hour. Heard of this unit before?
I think so.
Maybe. Kilowatt hour. Okay, so where will you see this? Maybe in like a laptop battery or something. It tells you how many kilowatt hour, which tells you the size of the battery. Okay, yeah. So what is 1 kilowatt hour? Let's try to figure out how much energy this is. Okay, so that is basically 1 kilowatt times 1 hour. You're using 1 kilowatt for an hour. Okay, but in terms of joules, okay, 1 kilowatt hour equals to 1000 watt hour. That is just taking away kilo because kilo is 1000 times, right? So what is 1000 watt hour? Well, a watt, W-A-T-T, this watt, is a unit of power. A watt is 1 joule per 1 second, right? 1 watt is 1 joule per 1 second. So I can say that 1000 watts will be 1000 joules per second. Make sense to you? Okay, right? Okay. And what is 1 hour? 1 hour in seconds is 3600 seconds. So multiply the two together, the seconds and seconds will cancel out. I'm left with 3600,000 joules. 3.6 times 1, 2, 3, 4, 5, 6, 10 to the power of 6 joules. This is the amount of energy 1 kilowatt hour is. Okay, so this is useful because now we see that, instead of writing this, big strange number, we're just using 1 kilowatt to represent it, and that's going to be quite useful in terms of calculation. Okay, so that is this 1 kWh. Typically, how do we do calculations like this? Typically, questions will say something like 1 kWh equals to some amount of money, right? So maybe it's 20 cents or something like that. And then you are using a certain appliance for maybe 3 hours every day. So calculate the cost of this for 1 month. So you have to calculate, okay, how many kilowatt is this? Then since 1 kWh is this money, then you just multiply it across. Okay, right? So that's how you can apply this.